So welcome to the second part in this mini-series about tone compressors in Darktable. I'm talking about Filmic, RGB and Sigmoid. In this second part, we'll be looking at commercial software and see how they manage the modifications of the data along the tonal range. That simply means that when we move exposure up, like we saw in the first episode, so we'll be looking at Lightroom Classic, Capture One, DXO Photolab, and then into Darktable to see the how Darktable manages that. Well, let's go. Enjoy the trip. So the image was imported into Lightroom. I made a virtual copy, and let's edit the first one. So in the develop module, I'll increase the exposure, and if you see, there's already a change. We do not seem to have the hue shift. We have very light oranges here. Let's go up to 3. So that's a good sign. We have very pale colors moving to white. That is kind of the expected behavior. And if I want to move down again, well, the method I found was to get, we'll make a selection. So I get the brush. I don't actually think I need the brush. If I kind of invert the mask, can I do that? Invert mask. No, it doesn't want me to. Okay, what I can do is brush. I'll just colour everything in. There we are. So I'm masking out the whole image. And now I'm going to go down to exposure on this layer and move back down -3. Okay, let's type that in -3. And there we are. So what I've done, I've moved +3, -3 on the whole image. And if we compare with the original image, the copy, the virtual copy here, there is absolutely no difference. Well, there is actually. I don't know if you can see this on YouTube, but there's kind of a very slight difference somewhere. Not much. So that is basically moving up, moving down. Lightroom seems to behave very nicely. Let's try Capture One. Same thing, Capture One. We have all the adjustments. I want to reset. I think those are done. Just make sure. So this is the image, and this is the second one, virtual copy. They are the same. Good. Let's try this. So exposure. Let's move up. Oh, look. Now this is unexpected because Capture One is changing the colors. Not at all what I expected. Now here are the LAB colors. I was actually trying to get what's the library now? I have the colors here, but I'm going to yellow. That's no good, is it? That is the kind of behavior you'd expect from a display referred workflow, not the scene referred workflow. And I always heard that Capture One was the best in color editing. So this is a bit of a shock to me. Let's add a layer and see if we can come backwards. So I have an adjustment layer. I'll invert the mask. So that is everything covered. And now I'll move to -3. And then we're back to the original, back to +3, -3. The oranges have come back. Let's compare the two. And there is a difference. Look, the top on this is yellow. It should be bright orange. Well, so much for Capture One. I don't know what conclusion to make of that, except I won't be using it. Let's try Photolab. Photolab, 2 copies, virtual copies of the same image. Let's go to exposure, increase exposure. I'll do it slowly. So the color conservation seems to be okay. No horrible yellows turning up. +3. So we have an overexposed image. And now we can go to local adjustments and right click, get a brush, color in, make a mask. I'm sure there's better ways to do this. There are get it right, and move the exposure down by 3 stops. Now, there we are. Oh, maybe 299. Okay, it's not faff around. The -3. We seem to have got the colours back anyway. Let's compare to the original. That's the original. That is the one with +3, -3. Looks as if we've come to the right place, the same place anyway. So we have good behaviour from Photolab. So how does Darktable behave? Here's the same TIFF file. In the darkroom, if you look at the pipeline, I only have 3 things. The input color profile, Rec 2020 is the working profile. Orientation, which doesn't matter. And the output profile, which is sRGB. Now I'll take a snapshot of that straight away as a reference point rather than making a virtual copy. Let's add an exposure module and shift the exposure to the right. Exposure, let's switch that on, and let's move the exposure up and see what's happening. And oh no, it's turning yellow, which means the colors are skewing, just like in Photoshop. Does that mean it's display referred and not scene referred? Well, no, because we do know that Darktable is, for the most part, scene referred. We're moving up, but we are not conserving colors. Why? Because Filmic does that. And in commercial software, this Filmic Sigmoid, these modules are actually done behind the scenes. We actually don't know how it's done, when it's done, or we don't have much control over them either. In Darktable, if you don't ask for it, well, you don't get it. So let's move this up. And, well, we can do +3. So right click on that. Right click, type in 3. We've gone up 3. Now, if I want to get some conservation of colors, Filmic RGB Sigmoid would be roughly similar. And we can see what's happening here. I have color conservation. Now, I'm not, it's in the automatic here, default state. We'll sort out the details of Filmic after. So it's type in 3. So if I remove Filmic, I lose the color conservation. There, I've got it back. New instance maybe of exposure. Type in a name, and let's move down and down. See if we get everything back. Well, it looks like it. I'll right click, -3, and we've got it. So now I can remove Filmic if you like. I don't really need it for the demonstration, and for the snapshot anyway, I have exactly the same before and after. Now, if I had Filmic, there is a modification made. It is actually doing some work on the colors. So I'll get a slight shift in tones. That's to be expected, but we'll sort that out later. So we are in a scene referred workflow for Darktable, and we have moved the exposure backwards and forwards, and we have color conservation. Before proceeding any further, I'd like to come back to how the exposure module actually works in relationship to the Filmic RGB or Sigmoid modules. So it's important to note that Filmic and Sigmoid cannot work if you haven't set exposure. Now, exposure will actually set a reference point, which is 0 EV. So once the module is set and you've done your exposure compensation, then for the rest of the pipeline, that value will be known to Darktable as 0 EV, and it corresponds to 18% luminosity, which is mid-gray. Now, this 18% luminosity is represented, well, it's actually transformed to 50% gray on your screen. That is because the human brain, our eyesight, doesn't work in a linear fashion. And for us, when there's something that's 18% of luminosity, then we see it as being in the middle between black and white. That's only because our eyesight works like that. And in the Ansel-Adams zone system, so if there are 10 zones from black to white, The mid grey is this one, number 5, and it is 50%. If you look at the RGB values, you'll find 128, 128, 128 in red, green, and blue, which is exactly midway between 0 and 255. Now, there is a gamma function, which is also called the electro-optical transfer function, EOTF, which will do the job, transforming the actual values of luminosity to the screen, so that what we see actually looks like, or what's on the screen actually looks like what we see when in nature when we look at the scene. And I think this is where I'm skating a little bit on thin ice with this. I think it's the last module. I think it's the output color profile that does that. I don't think it's done in Filmic or in Sigmoid. But what we can see in Filmic is that if we have the data here, there's a point which is orange, and if I look at that, let's put the labels on. The orange point is the value set by exposure, which is 0 EV, and it does correspond to 18% luminosity. So when we actually change exposure, we're actually changing what's called exposure compensation. We're actually, it's as if we were moving the data of the photo up. Now, if I move it just kind of up 1 EV, up 2 EV, up 3 EV, that doesn't sound ludicrous to anyone, but in reality, changing 1 EV, I think maybe everyone already knows this, but 1 EV is double the light. So we're actually doubling. So we see scales as if it's 1, 2, 3, but there's times 2, times 2, times 2. So if this is kind of 1, that'd be 2, and that'd be 4, and that'd be 8. Now, it doesn't really matter to us because our eyesight, as I said, works in a logarithmic fashion, which does exactly the same thing. If we have some light bulbs, so draw some little light bulbs, and this is 50 watts. And then we have one that's 100 watts, and one that's 200 watts, and one maybe that's 400 watts. So we're doubling the actual emission of light each time. Our eyes will not see that this one is twice as light as this one, which is twice as light as that one. We'll see an even gap. We'll say this is a bit brighter and this is a bit brighter, but it's the same. We'd see the same difference because, as I was talking about with the EOTF function, we see in a logarithmic fashion, and that is how logarithms work. So it's actually useful to us to think of this scale as being +1, +2, +3. There was something troubling me when I actually did the experiment in Affinity Photo. Remember this? I had my gradients. I add +3 exposure. The colours go wild. And when I come back, I keep this poor tone and I lose luminosity. Now, what was troubling me is that if I inverse the two, and I do -3 first and +3 after, I have no color shift. And I was thinking, why? Well, there is a little difference in brightness. We haven't come back to the right place. And why is that? Now, that got me thinking with all this. And what's happening is that, what I think is happening is that if I start by lowering the exposure, I'm dividing by 2. So I imagine a scale of numbers. So let's say I have a value which is of 100, which is one of the values of luminosity or one of the channels. Let's say we do the reds, but it could be greens or blues. And a -1 EV, that's 50, -2 EVs, 25, -3 EV, 12.5, and maybe Affinity in Photoshop can calculate with the decimal numbers, which I hope. That means that when I multiply, it's actually keeping something, it's not clipped, you see, because we'll actually, by dividing, we'll actually never kind of reach 0, will we? So when I multiply and I go back, adding 1 EV, 2 EV, and 3 EV, if the calculations are good with the decimals, then I will come back to normal. Whereas, so that is, first of all, we go this way, -3 + 3, we come kind of roughly back to the same spot. Whereas if I multiply first, I go to 200, and then I go to 400, which doesn't exist, 255, and then 255, you see. So it's actually adding 1 EV, adding 2 EV, adding 3 EVs. I've actually reached the limit on the display. And then I go back, not to the right place. I go actually divided by 2, 128, divide by 2, 64, divide by 2, and 36, which would be also an explanation not only of how I actually lost the colour, but why when I come back, it's darker. You see, if I do the exposure up first, did I lose that? I think I did. I think I moved it in the wrong place. If I do the -3 after, then I'm darker than before. So that is kind of the way I see it. Well, I hope you enjoyed that part. So we've seen that Darktable, being entirely linear, has a great chance of conserving colours better than the commercial software. In the next episode, we'll be seeing exactly how Filmic and Sigmoid work. It'll be a bit more technical. We'll see exactly what the black and white sliders do on the scene referred slide, on the scene referred scale, and then exactly how it gets the data onto the display. See you next time.